Uh, Hello, everyone. Yeah, I think now we have started the session. I think we're going to just take a 2 minutes breather just to ensure that we have more people on board. But at least, welcome everyone. Welcome, welcome, welcome. Yeah. Uh, Please note that this session is being recorded. Yeah, so, and this recording will be uploaded to YouTube. Yeah. This session will be uploaded to YouTube. Yeah. So, so read.ai is Peter. Yeah. So, uh, those online, please confirm if you can view the Q&A chat. Probably, if you can view the Q&A chat, probably you could leave a text such that we know we are all good. Yeah. So far, I think we have enough quorum. As we said, when it clocks 10 minutes past 10, we're going to kick off. Yeah. So, ladies and gentlemen, unfortunately, we have no lady on the call. We have no lady on the call, so I would say welcome, gentlemen. Yeah, but probably whoever will be watching it on YouTube, ladies and gentlemen, welcome to this webinar. Yeah, my name is Chanda Steven Cheune, and I'm welcoming you to this session. Building and managing cloud infrastructure in any programming language using Pulumi. So to get a deep dive of this session, we have an experienced, seasoned DevOps engineer, Kelvin Galabuzi, who's going to be taking us through this session. I know he's so experienced, and I can testify to this in such a way that he mentored me in this journey of DevOps. Basically, I used to do things, but I never knew it was DevOps, but he mentored me in my first days, in my early years of being a DevOps engineer. And I would say, yeah, I'm glad to have him facilitate our first session as the Kampala Devops Community. So the Kampala Devops Community is more of a group where we are bringing together DevOps engineers and probably upcoming people in the field of DevOps, because as we say, everyone is DevOps, right? So this means at one point or another, you find yourself interacting with DevOps tools. So I would say this community is going to be driven by such an initiative where we can come together, learn and connect, right? And so many things will be shared. If you look at the Pulumi session, any modern software developer, DevOps engineer, they work with cloud, right? And Pulumi as a tool enables you to create this cloud infrastructure using your favorite programming language, whereby we don't say these are things DevOps does. Even you, probably, if you're working on a project, you can go change those configuration files and be able to modify as you wish. Yeah, but the Kampala DevOps community will be having a couple of sessions. Yeah, this is the first. Yeah, we shall be organizing more, such as we can learn more, get to connect more, get to grow, build a space where we can come together and share. It's a small sector, I would say, in the field of IT, especially in Uganda. But us coming together and sharing knowledge will ensure that at least we get to accelerate and also get to learn from each other. Yeah, so I believe at least one thing I'm sure of, everyone here is part of the LinkedIn group, because at least that's where most the invite was shared. Yeah, but we have the LinkedIn group in place. We shall be using more platforms such that we can be able to connect, engage, and learn from each other. And also, in case one is stuck, you don't feel like you're alone or you're left out, but at least you have people you can get to talk to, people you can get to connect with, have a chat, such that you can be able to, walk through this chain of DevOps. Yeah, so I think without further ado, I will ask our guest, Kelvin Galabuzi, to take on the floor. Yeah, welcome, sir.
Yes, thanks for the invite to facilitate this very first session of the community. I'm happy that you actually started this up. We don't have so many communities like this, especially with the focus on DevOps. Most that I've seen before have been like software development, but it's good. Though, yeah, it's there's a tight integration between software development and operations. So, but I'm glad that I'm going to facilitate this first session. Yeah, so like you introduced me, Kelvin Galabuzi. I've held multiple hats before, but for the past couple of years, 5 years to be precise, I've been doing DevOps or SRE responsibilities. So, and so for um, this session, we are going to talk about Pulumi, and we'll first have a brief introduction onto what Pulumi is and what the benefits are, like why you should really consider it when you're planning on having that infrastructure as code roadmap, or planning on actually improving the management of your infrastructure. Um, so this session I'll basically be talking about Pulumi, and I'll also show a demo of how you can actually use Pulumi. Uh, so so the demo in the demo we'll be looking at three cloud platforms, that will be Azure, AWS, and GCP, so that we can be able to at least at least try to cover ground for people using different cloud platforms. So I'll go ahead and share my screen. Stephen, you can confirm whether you can see it. Can you see my screen?
Yes, we can view the screen.
The presentation?
Yes.
Right.
Yeah, I see some thumbs up from the audience. Yeah. I think right now, I think the view is on the other screen, probably.
Screen, yeah. So let me do this. Okay. Share the other screen there. So is that fine now?
Yeah, this is fine.
Okay.
Good to go.
All right, cool. All right, so yeah, so basically, so Pulumi has been around for a while, I think since 2017. But before Pulumi, there still is actually very many other infrastructures called tools. One of the most common ones is Terraform. It's known to be quite popular among the DevOps community, and that Terraform actually existed before Pulumi, if I remember correctly. So it's not been around for so long, and but if you look at the improvements it has made over the years, it's actually quite impressive. And you find that many teams these days use it in production. So the adoption is quite high lately. And if you've been quite involved with the DevOps community, you realize that it's a very popular mention these days in comparison to other tools or platform specific tools, or basically vendor specific tools. So you usually find it in the ranks of Terraform when people are talking about infrastructure as code. So um, Yeah, so what Pulumi is, it's basically it's an open source platform that enables developers to define, deploy, and manage cloud infrastructure using programming languages. So with Pulumi, you can actually use multiple programming languages. It doesn't support all, but it does support at least the popular ones, as you'll see. So when you're defining infrastructure, you'll find that you're going to use a language that you know, you're going to use constructs that you used to that are specific to a specific programming language. So that integration that Pulumi has with the programming language of choice is what really makes it a go-to choice for many teams. It's actually the main selling point of Pulumi. So in my experience working with Pulumi, I found that when working with developers, it's when you're actually trying to build an infrastructure roadmap, um, you find that when you're sharing the different tools that can be used to define infrastructure, they normally gravitate towards Pulumi because of that developer-friendly experience. They can easily understand the infrastructure. And so So that makes it a really good choice. And also, as we'll see later, there are a couple of things that it can enable you to do that you wouldn't find normally in a domain specific language like Terraform. So Pulumi has multi-cloud support. Can define and deploy infrastructure or manage infrastructure for different cloud platforms such as Azure, AWS, and Google Cloud. And you can actually also manage Kubernetes clusters using Pulumi code. Uh, so while it's open source, there's actually paid features. For example, as we'll see later, when you go into Pulumi Cloud, you find that there are enterprise offerings that offer more features. That offer more features than you would find in the open source version. But most times you find that when you're getting started, it's easier to use it. You can actually use it. You can actually use the limited features that you find in the free versions. But as your infrastructure grows, there is that needed capability of adding more features. There is that need of adding more features. So in this session, we'll not be going so much into details into the other enterprise level features, but during our demo, since there might be a waiting time while we're waiting for the infrastructure to spin up, I will create some more time. I'll actually go in and we look into a few enterprise features that may be nice to know. So with multi-language support, these are currently the languages that Pulumi supports. It supports Python, TypeScript, Go, YAML, JavaScript, and Java. So in this session, I'll be using C# because, as you know, Pulumi, one of the selling points is that you're able to use a language that you're familiar with. So it's common to find DevOps engineers using Python for doing most of their tasks. But like I shared in Pulumi, it's not really so much about using something that it's easier to use something that your team uses. So in my experience, just an explanation why I'm choosing C# as the go-to is because I'm more familiar using Pulumi in C#, given that I've worked more with backend developers or developers using C#. So I've gravitated towards using C# for this session since I'm more familiar with using Pulumi in that. But that doesn't mean that maybe C# has more features than any other language. But from what I've read before is that when using TypeScript, there is Pulumi is more up to date, like the providers, the resource providers that we shall look at are more up to date. And also, I think there's more features when you use TypeScript. I've never really gone into depth what the features are, but according to the different Pulumi demos and the mentions on the internet, it's one of the languages that they mentioned that they do constant development with, but that still doesn't stop you from using other languages. And I can be corrected on that as well. So, 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 so why Pulumi? So Pulumi, like I've shared before, it's the flexibility. And that flexibility comes with using multiple programming languages. You can easily integrate it into existing development practices. So this lessens the learning curve for the team in general. And also planning your infrastructure becomes easier because you actually start treating your infrastructure the same way as you treat your applications. So you basically follow the same development workflows that you would when designing and when building your application. So that is one of the reasons why you find it's easier to it's easy to use Pulumi. It's as you know, in most infrastructure as code projects, using different tools, there is a lot of planning that usually goes into it. Like how you're actually going to manage the workflow. So with Pulumi, it makes it a bit simple since you're actually using a language that you're already familiar with. So it's easier to implement those development practices. So another thing is if you've used Terraform before, while you can perform some conditional logic, you can't get into much complex conditional logic. So because you're limited by the capabilities of Terraform's hash configuration language. But with Pulumi, you are usually just limited by the language that you're using, like basically the capabilities of the language that you're using. So with that capability of being able to perform more complex conditional logic, it's easier when you're actually using Pulumi compared to tools that use a domain-specific language like Terraform. So the Pulumi's programming model is basically the process that Pulumi follows to ensure that you're able to deploy, provision, manage infrastructure. So it uses declarative syntax. Declarative syntax is basically you define how you want your infrastructure to look like. And once you define how you want it to look like, once you define how you want it to look like, you're able to establish or basically provision this infrastructure based on what you've defined. So it's not imperative in nature, though some of the specific components follow the imperative approach, but in general, it follows a declarative approach to ensure that your infrastructure is always on the desired state. And also, it follows an object-oriented approach. So you define your resources as objects, and you also define a correlation between these different objects. So it follows that object-oriented approach when you actually also defining infrastructure, because as you find infrastructure, you'd have a couple of resources that have different dependencies. So with its object-oriented approach, you can actually also link these resources easily because of that. Another thing is the resource providers. From my personal experience, it supports actually a wide range of providers. Initially, when I was starting out with Pulumi, I didn't know or didn't expect it to support a wide range of providers, given the number of years it's been in existence. But it actually supports quite a huge number of providers. It's only been a few edge cases whereby I've not been able to find a resource provider supported by Pulumi. That's as long as you're working with AWS, Azure, and GCP. It's the resource providers offers a wide range of resource providers. So, in summary, the programming model is basically the declarative syntax, the object-oriented approach, and also using resource providers to define those objects as you'll see in our demo. So there is more to the programming model in the documentation, but this is just a highlight for an introductory session. So I think that explains well for the introductory session. So then go to the provisioning of cloud infrastructure at Pulumi. So this provisioning, it's basically the same as we are basically following the same process as we defined in a programming model in the previous slide. So you define the infrastructure in the declarative nature, specifying the resources, which could be servers, the networks, the databases, or any other resources that you find within your cloud platform. So once that is defined, you can use the Pulumi CLI, or we can actually use the Pulumi Cloud, as we shall see. And with the Pulumi CLI, we can be able to see the deployment plan, that the hierarchy or the tree of the resources that are actually going to be created, or basically if we already change, or if we are changing something that already exists, we'll see the update plan as well. So quite similar to what you'd find in a Terraform plan, actually. So that is the second part of the provisioning of cloud infrastructure. Pulumi, you get to see the plan, what is going to be set up, the relationship between the resources, and then finally the state, the infrastructure. So the importance of the state is that it enables you to record, like it's basically a record of how your infrastructure is set up, such that if you want to make any changes, it can be able to detect that this is what you're planning to change, or this is actually what was changed when you're not around. Quite similar to, again, what you'd find in Terraform, as we shall actually also see. So this is basically it for the introductory session about Pulumi. If there are any questions I can take up, but other than that, we're moving on to the demo to start showcasing how we can actually provision cloud infrastructure with Pulumi. Sharing briefly, then I share my screen again. All right, so let me share my screen again. I'm going to okay. So is my screen visible, Steven?
Yes, I can see your desktop.
Okay, that's cool. All right, so hope that was brief enough. So let's go into the next phase, which is provisioning some cloud infrastructure. So we'll, so I have a project here set up, and with this project we're going to set up. We're basically going to set up infrastructure on Azure, AWS, and GCP. But we are not going to set up a lot of stuff. It's going to be it's going to be it's going to be see it's going to be a Kubernetes cluster, basically basic setup of a Kubernetes cluster. So, but before I get into that, this is a basic project layout. It's not typically how it would look like. It's not typically how it would look like in let's say if you're using it in production. Yes, it works, but in production you might find that you don't have only Kubernetes clusters. You actually do have like multiple resources. So you would have like you could have databases, you could have networks, uh, you could have many other resources. So in the project structure, you'd find that you would actually group those resources into folders and then specific class files whereby you are able to reuse those components among different resources. For example, like a, a network could be used by VMs, could be used by databases, could be used by anything that can actually use a network. And so some of these resources are shared. So you find that the structure would actually be different. But for the purposes of this demo, using a single structure, which is a good entry into what? Into knowing how to use Pulumi and understand how it's usually structured. So, but as we start, normally the structure of the program looks like this. So there's usually a program file, and a program file that is what normally contains the stack that you're actually going to spin up. So the program file is like the entry point into your application, just like how you'd find it in a typical program in the main method and that. So it's where you would define the high level configuration of your infrastructure components. So for this case, we have a program file that only has Kubernetes that has a Kubernetes cluster. And you find that in the program file over here is we have a resource group. We are defining a resource group. So the first example that I'm using is for Azure. So you have a resource group, but like I shared, it's easier to have these as reusable components. So typically, for best practices, you wouldn't like you would not put you wouldn't put this in the same class as the cluster. But for simplicity's sake and for this demo, we actually have them in the same file. So yeah, that's how it would look like. Basically, if you're actually doing this, following some best practices, separate them so that they are reusable components or modules, as you would see. So, all right. So the first one is let's look at Azure. So Pulumi, when using C Sharp, use constructors to define the resources. So our first constructor is basically the resource group. So, and this resource group in Azure is actually where we store the resources, basically the containers for the resources. And then we move on to the private key. So the private key over here, this is a resource that we actually going to use to create the cluster's SSH key. So we are able to create this private key by importing this library into Pulumi library. So that's what enables us to create this private key. And then we have another constructor, which is for creating a managed identity. So this managed identity is basically what the managed identity that we attach to the cluster that has the permissions required by the cluster. Let's say the cluster needs to call a database or needs to call any other external service and needs to have those permissions. This is a managed identity that you can actually use. And then the next part is creating the cluster itself. And then there's our constructor here for creating a cluster itself. And within that, we have a couple of properties that that the cluster would need. So there is like parameters which are required that are not supposed to be missing when you're, or basically properties in C#, which are required which are actually required that when you're creating a cluster must be defined as well. So, but before I really get into deep in this, and someone may ask where I'm really getting all this. This is not out of my head. It's available in the Pulumi documentation. Let me just go to the provider's documentation. Let's show you the building blocks. Let's see. All right, so, okay. All right, so to get started, normally it's the best friend is the Pulumi documentation. So to get started, you actually go in and look at the providers that are supported. So for our case, we're looking into the Azure native provider for the container service to create a managed cluster. So within the documentation, they have like starting points that you can actually use. And see here, they're showing you a starting point if you want to create a managed cluster with dedicated host group, Azure secret key vault. So look into here. So for example, if you see this constructor, which is a bit similar to what we have, it shows the different properties that you can actually set for your cluster. So these, such as the resource group name, which we have, we also have the Linux profile, this autoscaler profile, and many other properties that can actually be defined for the cluster. So you basically just use what the properties that are supported. So these are some of the properties, quite a number. Just use the ones which are specific to your environment. So this is usually the starting point for me, and I think for everyone out there that is actually using Pulumi. And as you can see, it's not only available in C#, there is in TypeScript, Python, and the other languages that we shared. It also shows you like shared the required properties. The source group is actually required because you need to define where the resource is going to be placed. So in a nutshell, that's basically what we are doing here. The only thing that we add is maybe we actually add the references to the specific objects that we've created now. Like for example, here we're trying to to reference to the managed identity that we created. So if we go into the documentation and look at this property and the structure that is required and some of the properties that it needs, you find that if you're assigning the managed identity, you would have to refer to the ID, which is output by the assigned managed identity that we created. Other things, Kubernetes version, if you want to, if you don't, for those properties that are not mandatory, you kind of have to, they actually have a default, setting, basically default parameter. So I don't know what it is. This is what I defined. Actually, I think it was 1.2 something. I just had to change this. So some of these properties which are not mandatory kind of have to, you have to define the specific names or parameters that you need or require. So we have the version, we have the DNS prefix. We also enabling RBAC, the agent pool profile. We're only going to have only one agent pool. In production. You'll find that it's more than this, but like I said, this is a demo. This is a demo, so it's fine to have this. So it's fine to have only one node. Then on virtual machine scale sets as well. So then we have our Linux profile here, that we're able to define the admin username and also the public keys that are required. Moving on, we have we also retrieve the admin credentials, which contain the kube configuration file. It's the file that we use to connect to our cluster. And also we add some role assignments to our identity. We grant a contributor role to the identity on the resource group. So that's what we are adding up here. And finally, we export the kube config file, which as you know, is what we usually use to connect to Kubernetes clusters. So there are a couple of outputs that can be generated, and this is one of the outputs. But there are very many more outputs that you can define, such as the API server endpoint, anything that you want to use as an output that can actually be reused in that can be reused by by something else within your infrastructure, such as you find that you need looking for a good example to use here. But in a nutshell, it's a couple of outputs that you can have. It's not only just a quick config file. It's dependent on your requirements. So this is the basic setup, and this I use the boilerplate from Pulumi. So it's like I shared, it's if you're working with a documentation and you're setting up if you're trying to set up the basics, if you're trying to have the basic setup, it's easier. It's only when you're actually going to have a couple of modifications, which is what typically happens in most environments, that you would have to make a couple of adjustments and also change the program structure. But for purposes of this webinar, keeping it at the introductory level, make sure that at least to facilitate for everyone attending is to make sure that we have it in the simplest way possible. So that's the program.cs file. There is also a much better way that you can actually organize your code. From my experience, when I'm using .NET, I'll find that, so for example, I would use a provider that currently is on .NET 6.0. And then I'll find a provider that it's a bit up to date, maybe on .NET 8.0. So some of those in personally, when I was using a project structure whereby I'm sharing the CS, whereby I'm sharing the CS project file, I would have some challenges with backward compatibility for some of the NuGets or packages that are on an older .NET. So it depends on what your team that actually really requires, how it really wants to structure the code in a way that will actually work for them. So the other things over here, these YAML files, these are specifically configurations for Pulumi. So this configuration can take in multiple values. This that I have is just the location that I'm actually going to set up the cluster. So it's nothing much here, but it can have more, can actually have more configurations that are specific to an environment, and you can also have more than one stack configuration file. So for this is dev, but you can have more or staging production that has different configuration values as required. And that's what it's all about, is YAML files. So to speed up this in Azure, you don't run it as a program. You don't run it typically the same way that you would a web application. If we are using Pulumi CLI, see over here, we're using Pulumi CLI, for example. See a moment here. Okay. All right. So if using a Pulumi CLI, just go in and spin up the command line. So what we typically do, this environment is actually already set up. Oh, okay, it's not already set up, but I already logged into my Azure. But what you can typically do is, for example, for Azure, you have to do an easy login, and with that, it will be able to redirect you to your web browser, whereby you sign into your Microsoft Azure, and then once you've signed in, you set the default subscription. So I can't do that here because that's kind of like sensitive information to show my subscription values and all that. But that's typically the process. So you log in, and also you set the default subscription. That's if you're actually using multiple subscriptions. So that's the first entry point when you're starting to use the CLI. The next thing is you sign into Pulumi as well. It's a Pulumi login. And with Pulumi login, it's to share it briefly over here. It's basically the cloud offering that I talked about in the slides. It's basically the cloud offering that that houses your stacks. It's not mandatory to use Pulumi. It's not mandatory to use like Pulumi Cloud, but if you kind of want to easily manage your stacks, it's Pulumi Cloud can actually do a good job. At that. So when you log into Pulumi Cloud as well, you use the command line to log in here, such that your command line has access to Pulumi Cloud. And most times, you can actually also use personal access token as well. You can use a personal access token as well to enable a seamless. Yeah, so just like this personal access token that I'm having over here. to be able to log in using the CLI. Okay, so let's get back to this. So that's what I have over here in the CLI. Underneath the CLI, those logins have to be worked on first before you can actually start provisioning. So to get started with this, I'll do a Pulumi app. So I currently have no stack for my Azure. Actually, did have a stack. See, so it's dev. Okay. So the Pulumi app, it's basically going to show us the plan. First, it usually restores the NuGets that are required, the packages that are required, and the different plugins. And then it shows us the resource, the tree structure of the resources. So like we had seen in the code, we're setting up the resource group first, and then the private key, then the managed identity, then the role assignment, and then so the managed cluster. So when you define the dependency on a specific, resource, it makes sure that it defines that resource first. So for example, just like you saw with our managed identity, we are referring it to it over here. So that means that we need to have this created first. So it kind of uses those explicit dependencies to know what to set up first. But if you don't do that, you actually do get errors. However, there is also a depends on attribute that can be used to make sure that a specific resource, there are specific cases that I've actually also faced, whereby, for example, a resource needs to be really ready fast. Like, so let me just use the example that I faced in my case. So there's a time I was setting up a front door profile, an Azure front door profile, and the front door profile takes a long time it takes a long time. So trying to remember exactly what happened, but since it takes a long time, and once Pulumi is starting to create the resources, when it was creating the resources, it was like no wait time. It wasn't like identifying, since I had not really like defined the explicit dependency, as that parameter was not available as an attribute for the phone draw profile to take up. I had to set up a dependency that actually, before you finish creating this, make sure this is created first. However, it's like that's also similar to what you find in Terraform with the depends on attribute. So that's also available in Pulumi, but many times, if you can actually require, if the resource that you are creating or the constructor that you have has attributes that within those attributes, or basically parameters, within those parameters, there are attributes that you can use to explicitly define the dependency, just as how we have over here to the identity, it does it automatically. So in cases such as that, you don't really need to use the depends on. But in the other case where you can't really have the attribute. If you can't like really connect the attribute to the other resource, you sort of have to say that depends on. So I'll look at the details first before creating. Details first is basically the same thing that we are doing. So it shows you the resources and some of the outputs that the resources would have. And all right, so since we have this, then we can say create, go on and create. So you notice once we are creating, it also shows view in browser. This view in browser is basically the link to Pulumi Cloud. this is just my organization name. So you can actually also view these updates from within the browser. Some teams don't use Pulumi Cloud, especially when they are keeping it like they're not really planning on using it open source. So you can store a state in you can store a state in let's say like Azure Blob Storage or S3. So just like how you can actually also do it with Terraform. So the teams that actually don't use Pulumi Cloud, that's where they do store the state. So this feature is actually available to people that are using Pulumi Cloud. So that's like their selling point. So as I just shared it, make sure these are created first. So as you saw, the resource book was created first, and then you have the private key, then the other resources as well. And now it's making sure that the cluster is getting created as well, because all the other dependencies have been created. So while this is creating, let me go to Pulumi Cloud and show you. It looks like so we have the stack over here. So the stack was not existed at first, so it shows that we have the dev stack spinning up. Sure, you can have multiple stacks over here. Okay, so let's go into the dev stack and this. All right, so it's updates. Okay. It's a mirror of what is already going on in our current it's going out in CLI. All right, so yeah, you can view the update from here as well. Okay, so yeah.
So this is really interesting, yeah.
Yeah, but if you use Terraform Cloud, it's a bit a similar thing when you're actually setting up infrastructure.
Yeah. And
So
probably
hmm?
was
So
I remember in
they
Terraform you had to
hmm.
plan, which is more like viewing a simulation of the resources to be created, then
Hmm.
such that it even identifies the errors, say in your configuration files, right?
Yeah. E-
Yeah, such that
Even even Pulumi, actually, you can do a preview. It's just that I did an app, but you can
yeah,
still do a preview of resources and it basically shows you the plan.
yeah. Because I remember when you share the bit of attributes, it's similar to say whenever you're creating resources in a GUI on the cloud provider, probably the things you're
Mm.
providing. Say when you're creating, say, managed cluster in Azure, you keep on supplying all those fields. And if you can do these things programmatically, that means you can have the same environment provisioned on Microsoft Azure, on AWS, on GCP, just in case if one even ever crashed, you can easily spin up the same thing quickly rather than going to the UI, configuring all this stuff. So I would say this is really insightful, and probably I think the audience can get to appreciate Pulumi because as you can see, guys, you can use any programming language from Python to C sharp. Yeah, I say thumbs up. Yeah, it's really interesting because I would say all of us are DevOps, you know, because when a DevOps engineer goes on leave, that means, yeah, any software engineer can chip in, right? Because they know where to
Yeah,
touch. Yeah, really interesting.
yeah. It's that's those are some of the things that you see, like with infrastructure as code projects. They do take time, but you appreciate their value once, especially for teams that already set up the infrastructure with without using infrastructure as code.
Yeah.
The projects do take time, but once you have like infrastructure as code, or you're defining infrastructure as in code, you get to appreciate what's going on. As you will actually also see when we reach the AWS part, because for the Azure part, I'm not going to do a pull request or use GitHub Actions, but I want to use that in the AWS part to show the workflow that can be similar to
Over
deploying an
to you.
application. Yeah. So that's awesome. So we have the kube config file as an export. Like I shared, you can define some exports that can be used. This can also be an output. We're not really using it. And that's so that's the cluster that has been created. We can still go on ahead to see how it looks. Azure. So let's see. Okay. All right. So since we didn't define the resource group name, we just defined the resource group. It generates random names for it. But obviously, in a real environment, your resource groups have got to have the right naming convention according to your needs. So this is the resource group that we have that has the cluster and the managed identity. Basically, the key resources that we created. That's the resource group as well. So going and look into the cluster. So we can see some of the things that we created. Let's look at the node pools. Look at the agent pool that we created over here. It's only one node. Yeah, it's only one node that is part of a virtual machine skill set like we had defined. So basically everything takes that once you've defined in a declarative nature infrastructure, nothing is not as you defined it. Like it lessens the mistakes that you'd actually make. Only things that you did set up, because as we viewed in the Pulumi docs, there is a couple of parameters, properties that you can add. So only those things that you did define the properties are what could be different. And also, as you know, not everything on a resource can be changed, just like how you find in the even when you create resources using the GUI, find that there's some resources, once you've created it, there are some things that you can't really change from the GUI. So the same API calls that Pulumi is making. So some of the things you can't change is a bit consistent with what you do in the GUI. So the resources that can be changed, it's according to the resource provider's maturity level. So if the provider supports configuring storage, which it does, you're able to define that within Pulumi. If it supports adding service mesh or this supports adding GitOps, you can actually do that. So yeah, but for our setup, it's a simple setup and it's provisioning. But if you reach the management part, as we shall see with the AWS, so see how we can make some changes to our resources as well. So so this is how it basically looks like in Azure. It's not that different from how we do it in AWS, but we're going to cover that since we don't want to lean on towards only one cloud platform. So if we move on to AWS, let's just close this program file over here. If we move on to AWS, you see it's basically the same structure that you're using. The constructors, basically still using the constructors. So we have some variables here whereby we are defining the configurations that we want to use for our cluster. So with here we have the minimum cluster size, the maximum cluster size, the desired, the node type for our nodes, and also the VPC side range that we use in AWS. So then over here, this chapter, we are going to create VPC. You can see here, so with its name, EKS VPC. So, and then we enable some of the properties that it accepts. So a VPC also has many properties. It's just that we enable those that we find fit for our environment. But take note, like I shared earlier when we were starting with Azure, is that normally, since this is a demo, we have things set up in the same. We have things set up in the same program file, but normally you'd actually split your resources in different classes or different files as well. So yeah, so that's what would typically happen if you're following best practices, and also yeah, basically resources in their different files. So we have the EKS cluster over here, and the EKS cluster we're also referencing to the VPC because the EKS cluster can't be created without VPC. If you try to do that, it would fail. It would fail in the CLI when you're trying to provision the infrastructure. We have some public subnets over here, which we use for load balancers. Then we have the private subnets, which we use for the cluster nodes. Then over here, we go and reference to the instance type and the other configurations that I set. If you don't set these configurations, Pulumi normally comes up with its default values. So then, so basically, you can see the one for AWS. It's simpler. So we kept the things are kept to a minimum, but once we reach the creation process, there is a series of dependent resources that actually would have to be created, such as security groups, such as policy assignments, and with this demo session. And like I shared, since most of the things are not since like when you some resources are not mandatory, Pulumi generates some of those for you, but typically you would actually have to set those up just to keep the complexity low for this program. We'll just let it set up those and we view them in a tree. We also have some output here, VPC ID, so and also the kube config that we can use to connect to the cluster. So typically it wouldn't look this simple since you're going to make those customizations like I've shared. It wouldn't look this so let's go on ahead and try to see how this does here. Do I need to go there? Okay, so CD, then CD. Okay, all right. So for AWS, it's still the same thing. I still need to have some credentials set up. So I did set up some credentials already. There's an access key ID over there. This is a sandbox environment that I use, and I do have secret access key, and then the default region is US East 1. The usual AWS CLI configurations that we have. Since you're already logged into Pulumi Cloud, we don't need to log into it again using the Pulumi login command. But so we can go ahead and look at how it could look like over here. So let's do a Pulumi app, AWS, create a new stack, just name it dev with a stack, stores, packages. So doing this thing, let me log in. I think it's that. So Yeah, so you can see most of these resources were defined. It's giving the defaults. It's giving the defaults, but in a real environment, you basically have to set this up on your own and ensure that uh, the resources are actually connecting to, they actually define the way that you'd want them defined. Let's just have an overview of this. So this is our stack. And then the first thing is creating is the VPC, as you can see. So in the tree structure, so in the VPC, we obviously do need an internet gateway, which is what would link to our public subnet. So then in that same VPC, we have a couple of subnets. There's this private subnet, and with that private subnet, there's a route table and also a route table association, and also a route as well. Then we have, this is the first subnet. Then we have this first public subnet. This is a private subnet, this is a public subnet. And then with that as well, we have an EIP, plastic IP, and route table. So, and also in the public subnet, since it's public, we're putting the internet NAT gateway over here. So ahead, couple of route tables over here for the different subnets as we've seen earlier. Then down. Then we move on to the cluster. So the cluster, like I shared, some of these things are not defined, but you find in the environment that have been defined. So it's defining for us a role that we can actually have with a role policy attachment as well. So then another service role as well. Then some security group and CNI, and then some other security groups as well that are typically needed by the Kubernetes cluster, the EKS cluster. So for resources that you do not define, but rather for properties that you do not define that are not needed, so rather that are not mandatory, it creates those for you. But if you know you need them, you kind of like have to create them and link them together. All right, so I'll go ahead and to pull it up over here to start with the VPC, since it's the first resource that is required. Right, so while that is creating into our stacks over here, down here you can see the AWS stack was created. It's going on, still creating. So this one takes some time. So, but if we go and still review these take us to what we're talking about. Okay. So if we go to the Pulumi docs as well and look at creating the cluster resource, it would still give us some of the things that we can use in our, some of the properties that we can use, some of the properties that we can use if we want to make additional configurations. Most properties that are not defined here, it's usually that they are either, even in a GUI, you cannot really, basically it's, most times it's because it's the provider has not been updated to support that property. We do have the properties which are similar to what we have over in the code, and the VPC config is a mandatory one. Okay, so these are the outputs you can have, outputs that can actually be used as inputs into another resource. Okay. Over here is a couple of many other resources that are supported. API Gateway, API Gateway V2. Yeah, it's quite a number of resources that are supported. If it's not here, then it's usually not supported. But they try their best to support as much resources as possible. Okay. Um, um, let's see. So this one for AWS is going to take some time. I know it takes some time getting the EKS cluster in AWS, but not a very long time. So
Probably just to chip in there,
mm,
could we look, say, at S3?
okay,
S3 more like the Google Drive for AWS. Or just see
okay.
probably the configuration file, properties to add.
Oh yeah, S3.
Yes.
Yeah, S3 has lots of support over here. There's all the resources that you can
Setting up a
configure.
bucket.
Yeah, and you also sometimes actually something
Wow.
that I would need to mention. Yeah, so there's the yeah can set up bucket. This is the simplest thing that can be done. Just as storage accounts are with Azure as well. So a couple of properties that are supported. For
Set
some
all
reason,
the
when I was starting to use Pulumi, I thought I would use YAML, but since it's a bit simple, but yeah, but
I'm a fan of YAML, but I think here the configuration file can grow really, really large. Because if
yeah, and
S3, if you compare the C# or Python code and you look at the YAML code, you see that the list is
yeah, it's
expanding to
really
become really large.
yeah. So the thing was how I ended up noticing it was the conditional logic.
Yeah.
Like you can't do so much with conditional logic in YAML. You can do something, but not to the level of robustness that you'd find in a general purpose language. But I actually thought I would use YAML at first, but then it also came back to what the developers were comfortable with, and it's a team thing. So yeah, it ended up being C#.
Yeah. At least one thing I've liked is it's open to any language above. Because me as me personally, I'm a fan of Python. If you could first click on Python and I see with Python, I could just edit out probably the key things I always see when I'm adding in the UI, and I'm able to manipulate them right here in the file,
Yeah,
which is really, really, really insightful. Like this one was creating 60 resources.
the AWS one takes the one for Azure is the one which takes the shortest time.
Yeah.
Um, there is a nice mesh. There are other things that you can actually check out. Is you can actually there is also Pulumi for those interested. There's going to be a Pulumi conference. There's going to be a Pulumi conference, I think, next week. Where they do share some new things, 2024. So in case you're interested, you can check it out. Check out the lineup, some interesting things that they have.
Yeah.
Different people talk
There's a
about how they're using it.
there's a question for you in
Result.
the chat. Question for you in the chat from Sang.
Okay.
What Yamo's backup?
Oh, my team's taking long to show the message. It's about, I'm only seeing
Yeah, so
Uka and you. Is it, oh,
so
chat, not Q. Okay, it's okay. It's okay.
it's in the chat.
Yeah, I've personally not used Yamo like for Polami, but yes, Yamo is easier because it's like you're defining stuff in a language that is more human readable. But when I've when I did some research, I saw that when it came to doing like more conditional logic, for example, can I use for conditional logic? Yeah, like when it came to use like more conditional logic, more complex scenarios of conditional logic, you would not like uh be, like it would not be able to achieve it. So, but if someone has used YAML, it would be nice for me to know. I've personally not really used it. I just did some reading around, and it was. Yeah. I've not used it for Pulumi. I've used it in other instances, like for Kubernetes manifest files, but for spinning up Pulumi infrastructure using YAML is something I've not really done. However, in platforms like GCP, you have options actually using YAML and JSON. Hmm? Yeah, when you're spinning up the infrastructure. I don't know how to what depth they do get when it reaches conditionals.
Yeah,
Yeah, but YAML is easier. It's an easy thing to start with.
true. Hopefully, yeah, we shall have more questions at the end. We wanted to first go through the demo such that we
But it's
get the
okay
gist
over
of it.
here. It's
Yeah,
okay. It's almost done. It's some questions can still be asked. I think this is almost done.
yeah,
Hmm. Another limitation I have, I would have set up the one for GCP as well, but I'm using the free version of Pulumi. So I'm entitled to one deployment at a time. But I did do a destroy before while I'm running a deployment and it worked. So I don't know what they consider is a deployment when I'm only setting up resources. So, but according to
yeah,
Pulumi Cloud, I'm entitled to one deployment at a time, according to the free tier that I'm using.
yeah.
Um, yeah, so there is that conference that will happen. Someone is interested, you could attend it. There is also there is also Pulumi AI. Yeah, there is Pulumi AI. If you want a starting point, you just need to kind of get maybe how you can structure your program or how to set up a specific resource. Yeah, they have Pulumi AI that you can use to generate some code. It's just they just trained GPT for on their documentation for this. I've
Yeah.
not really had a very good experience with this. I used it. I think this was announced in the Pulumi session, in the Pulumi conference of last year. That's when they announced this Pulumi AI. I used it, but it's not that sometimes it would work out of the box. As you know, generative AI things,
Yeah,
yeah, you have to do some debugging sometimes.
yeah,
So
but
yeah, but it kind of gives you an idea of what you can do. Gives you an idea.
I would say the audience at this point could become like a go-to tool. You use this as a go-to tool Then you reference the documentation, to just probably get more information and, probably spice it up. But
Yeah,
now this even makes the tool more interesting.
yeah. I've not had a very good experience with it.
Yeah.
I ended up using that documentation in my case. But it's a good starting point. I think there is something it did for me sometime. There's something it did for me sometime that I had trouble finding it, a documentation that I didn't know it's a property I could define on a resource. Like somehow, maybe it skipped my eyes, something. But it's still a good starting point. Could be. But when you get complex, like my query was a bit complex.
Yeah.
It was a bit complex for it, so it made some mistakes. But I think for the basic start, could be good, and maybe they actually have improved it now because it's been a long time since I last used it.
Yeah.
So right, so our stuff was created. Let's just go into AWS and see how it looks. Uh, See over here. I get the sheets. Okay. Um,
I think just a disclaimer, for security reasons, these environments
no,
are probably for development, be accessed, the account ID won't work for anyone.
yeah,
Yeah.
this expires in it's expiring in the next 2 hours actually. So
Yeah.
so all right, so let's see. Let's start with some of the things we created. Okay, so here's our VPC. See, and also see the resource map over here, with the subnets that were created and the routables to which network that they connect to. Subnets and routables, security groups as well. Everything that has been declaratively shared is actually created.
The new VPC view wizard is really cool. You see how your resources are all interconnected.
Yeah, and you see that like the default when it's set up NAT gateways for the different public subnets. That may not be the case for everyone. I don't think everyone puts things in high availability, but is that like the default? I don't think so. Yeah, so I was going to ask whether that's the default in EKS, but that's not the case. So yeah, so this is what it has set up, but can always can be adjusted according to your environment, but then actually you have to define the NAT gateways on your own if you're not going on the default config. Right, so let's see cluster over here. Cluster is being created 1.30. So for this, I didn't even really define the version. That means the default is that. We'll go ahead and look at compute, shared nodes over here. Desired cluster size is 4, so we have 4 of them on T3 medium. Yeah. Okay. Starting points as well. So yeah, with the declarative nature, everything is set up the way it was supposed to be set up in a pod. So what we're going to do, so I'm going to come in and pull up, try to commit some of these things to Git, and then we can, start looking at first flow. All right, so it should directly to I don't have any branch protections. Okay, so let's see. The repo is public, created 2 hours ago. Right, so I have this over here. For GCP, we'll probably do GCP last. Okay, so the next thing that we are going to do, we are going to use GitHub Actions to you can use GitHub Actions to actually provision the infrastructure if it doesn't exist. You can actually also still use it to update existing infrastructure. So we are going to use GitHub Actions to update the existing infrastructure. So let's do this. So the first thing that we need to set up is set up some security secrets. Let's go to actions. Then secret. I need to get something here which is sensitive. Let me that. I'm looking for my Pulumi person access token. Actually thought I stored it somewhere. Yeah. Yeah, this is why it's good to test things before doing a demo.
At least this is not like Fufa TV. This is
Yeah.
better than Fufa TV.
Yeah.
So we're in production, but at least things are not crashing yet. We're still solid.
I think I found it. I don't want people to view it. So let me first take this on this side and add it.
Yeah. Yeah. So guys, the session is being recorded, so we didn't want to share sensitive data with such that anyone watching the video can get to reuse this if they have, say, not been rotated. Yeah. But yeah, at least we can appreciate, yeah, we are being secure in how we are presenting, which we also probably encourage everyone to take on. So actually, probably I could probably chip in a quick question meanwhile as you add it. Yeah. So I remember when you're locally doing most of the work, you were using probably your own user account, right? Now, for example, for CI/CD pipelines, in most cases, we set up dedicated users, right? I could say roles or users to be able to achieve the intended functionality you want CI/CD pipelines to achieve, right? So for this case, you're adding your Pulumi key such that it can access the Pulumi cloud seamlessly, right?
Yeah.
Uh, so does Pulumi have official GitHub actions?
Yes, that's what we're going to use.
Interesting. Yeah, that's nice. So this further emphasizes that they are actively supporting and
It's it's actually quite popular these days, especially for I realize it's if you're working with devs or DevOps engineers from a development background, they like it.
yeah.
And Terraform is actually easy, but everyone likes something that they are familiar with so that they don't really waste time. Like Terraform, you find that there were these stuff like TerraGrant, whereby I think you have to do that improves on the way you modularize your code. So with Terraform, there's a lot of add-ins that you kind of you have. I don't know whether right now, but you kind of had to add. So that's why I find like some devs or many teams want to use Poland because of access key. Because it's because you can easily adopt same strategies. Even test, you can use the same test framework, PyTest, Python.
Yeah.
Yeah, so you can even easily build your tests using the same testing frameworks. So
So CDKs are really the way to go.
looks like it
So
these days.
look, the one would ask, so we have this issue where say certain attributes are not in the providers provided by Pulumi, yet even cloud providers, say AWS, are now also having their own CDKs, right?
Yeah,
So why would one opt for Pulumi over a native cloud provider's CDK?
just a moment, trying to make sure I'm putting the right secret key.
Yeah.
Access key. You don't want our action to fail on the first time.
You want to see red X's. Getting the region code, yeah.
Yeah.
US East 1, North Virginia. Probably could even talk about that bit of latency, We have regions closer to us.
All right, let me bring it back to make sure I've added the right thing. So there's the access key ID, the region, the secret access key, and my Pulumi access token. So after that, let me go into Pulumi Cloud. Limits. Limit. integrations. In the integrations, I have the GitHub app, which is used to automatically set up the action that is required. So go in and select my repository. Repositories. I'm giving the Pulumi app, which had the Pulumi GitHub action that can be used to provision the infrastructure using GitHub actions. You can also set it up manually using there's a YAML file within the documentation that is used by the GitHub action. But since we have that, it kind of makes it even easier for us to set up. So yeah, so we have that set up. So what do we have over here? So go into the LS dev stack, then do this. This was our previous deployment, which completed a couple of minutes ago. So over here to the integrations settings, then integrations. When you have the integration set up, then the next thing is to configure the repository that we are getting from. So it's GitHub. This is a repository that I configured for the GitHub action. And trying to think, should I I would want to have a CI build as well. I have a CI build as well. Let's come over here. Select the folder that dealing with. Let's see. Okay, so I need to add some variables here over as well. So let me take my screen back. Just going to add the secrets again over here to this section for environment variables. Access key ID. Yes. Okay. We have this added up. Save the deployment configuration. Have the environment variables here set up. Allow me to access AWS Cloud. And I don't think it even really needs this down here because we already have these keys already defined in our repo. So just adding them up there. So now to the folder of AWS. Okay, so right, so let's go and let's make some changes. Let's change this cluster size to 4. Change the node to T2 medium. The cluster size 3 here. Leave this at 6. Okay. And so I've basically changed the max cluster size. So rather, I've changed the desired cluster size and the instance type to T2 medium from T3. Let's see. Let me create a branch. Bring the changes to dev. Yeah. Say modify is push over the dev branch. So when you're making modifications, you modify things that can actually even be changed. Like for some things that are created cannot be changed. All right, so yeah, so it's pushed over the dev branch, and can create a pull request over here. I'll let it be modify cluster size, create a pull request. You can see our changes down over here. This from 4 to 3, and this from T3 medium to T2 medium instance type. Create a pull request here. All right, so let's wait and see if our things work. If actually the GitHub action can work. So since I configured the GitHub action to integration to can provide pull request comments. So if it can provide pull request comments, that means I really don't need to comment out my PR. It will use the changes that it shows from the Pulumi preview command, which is like the plan. So it helps me with commenting that out. So I added this out. So let's see the other thing that we did. We also said run updates, run previews before request. Yeah, that's on. So then run updates for pushed commits. Yeah. So when I commit that file to main, it will be able to now update. So it's just going to first preview. Oh, God. It's just going to first preview, and then it will, once I merge that branch into main, it will be able to update. So let's see what it's doing over here. So right now it's saying it's previewing, so it's running a Pulumi preview. that will help us see whether whatever that I've changed over there is something that is actually updatable. So go into details over here. Shows this is in progress, which you can actually view in Pulumi Cloud. Okay. So go into here, Pulumi Cloud, and go to the overview. You should be able to see that preview going on. It's the preview running over here. Still letting the action do its work. Let's wait for it. Yeah, this is similar to a CI build, whereby actually before you merge, you can see whether your build is passing successfully. So for your open PRs, so since it has passed all the checks, like the CI build has passed all the check, so it shows see and yeah, so this is a preview. So it shows that these resources, the resources to change is one to update, or basically one to replace. I don't know what I replace it. I know is that okay. In the node configuration, the node configuration that is used by the nodes, it's going to replace it. Okay, so then we'll have the two changes which we made to the cluster size and the instance type. So this was just an update, a preview. The change has not really yet been made on our infrastructure. And you can also see over here that the PR build ran successfully, basically giving us the same information. The bot commenting out the change that we are planning on making. This can be useful for someone trying to review the changes that you made, basically good development practices. Okay, so let's go back into our cluster over here. It's fine. So I'm going to go and merge this pull request. Okay. So since I'm fine with the changes, merged, so this should trigger a deployment over here that you can see is actually starting to run, whereby it's actually now making the modifications to the cluster. So it had not made the modifications. We are just having a preview of the changes that were going to be made. So if I come back over here, go to deployments, you can see the deployment 2 is starting. And this is an update, as you can see. The previous one was just a preview. All right, so let's see how it's going on over here. Taking some time over here, so. Stephen, you had mentioned something to do with CDKs and.
Yeah. So the usage of Pulumi over using, say, a cloud defined SDK. So Pulumi and say the AWS CDK.
Yeah, I don't know. I don't know how good the CDK is, to be honest.
Yeah, it's active, it's under active development. They promote
Mm.
it, but I think even me, in my opinion, because with the multi-cloud and
Yeah.
the
Mm.
disaster recovery approach, you want to be able to spin up something in different clouds of the same specs easily. Yeah,
Yeah.
but I believe at this point we could also have anyone wants to ask a question, feel free to type it in the chat, or I can be able to unmute you. Yeah,
So it's updating right now. It's actually making the
yeah,
update itself. The node configuration, node launch configuration, it replaced the instance type. Like that, the new nodes actually come up with that new instance type. Oh, this has actually taken a long time. I thought I thought we would be able to, because the session is supposed to end at, is it right now?
yeah.
Yeah.
But I believe as it
So
updates, we can allow questions to come in. So I think for now, what I'm doing is allowing mics for users. So feel free to unmute. Yeah, at least one by one. If you have any questions.
yeah, another thing is yeah, so I wanted us to do whatever, but we are caught with time, but it's basically the same thing. I wanted us to do GCP as well, but yeah,
Yeah,
as I was right not to put so much things into this. I thought the time actually was. So we shall not set up this one, but it's basically the same thing that we were going to go through.
yeah,
Yeah, at least we have done for AWS and Azure. So we can just let GCP out. Is it will eat more time.
yeah.
So
Uh,
there is also, you can actually also move from Terraform to Pulumi if you want to. It's possible. Can you can actually, this is the thing. You have, so yeah, so the update is done. The update is done to the stack. Yeah, so you can see the class size has changed to 3, and also we have the instance type to medium as well. We want to have it. Yeah, so that's how it would look like in a pull request workflow. You have the integration with GitHub. It basically look like that using GitHub Actions. Deployment is over here. So it's actually possible to move from Terraform to Pulumi if you want to. They have, they do have this, they do have a way that you can convert Terraform programs. I think Terraform programs to Pulumi. That would be something for that's basically a demo of its own. But
yeah,
I have a way that you can actually move from Terraform to Pulumi. Then they also have, you can migrate migrate existing infrastructure to Pulumi as well.
that was going to be my question. More
Yeah,
like Terraform import. Yeah, say I've set
yeah,
up resources. How can I say have Pulumi import these four things so that I can at least get started easily?
yes, yeah. They do have this
Yeah,
importation as well for resource types that actually supported. So basically, the resources that you import, you have to have providers, basically resource providers.
Yeah.
The resources supported for you to perform the importation. When you do the import, it generates the code for you in the CLI that you can start with.
Yeah.
Most times, yeah, I've not really used that. I used it once to see if I could import some stuff, but the stuff that I had was a was a bit of a complicated setup. It wasn't like a single resource. So like there were like dependencies between the resources. And I noticed this was really good with a single resource in my when I used it. So yeah, it wasn't really a shortcut for me, but maybe there are people who have used it in a way that I didn't use it.
Yeah.
So yeah, so so that can be done as well. Like move from Terraform to Pulumi, you can also import distinct resources,
Yeah.
Pulumi as a starting point. Yeah.
We have a question in the chat from David. Feel free to unmute.
Is it?
Yeah. Uh, your volume is a bit down.
Is this better?
Yeah,
Yeah,
that's
yeah,
better.
that's better.
Yeah. Okay. So thanks for the for this session. It's really really deep. I think I've learned quite a lot. So I guess my question is actually two. One, how do you install various packages on the various instances that you've set up? And these are like Linux packages that probably your application needs to use to run smoothly. And then two, say I already have like an instance on Linode, which is like my current setup. How do I now move from the existing setup of the VPS or the VPSs and now start using Polani without affecting any services that are running or causing any kind of downtime? Yeah.
Okay. The first question was how you install, let's say, like Linux packages using Pulumi
Yes.
on a
I think
Linux instance. Eh?
that. Yes.
All right. So if you're going to do that, then you would need to have an integrate. Okay, it's not something that I've done. I'm just going to state how I think would be my starting point. Um, since um, since when you're setting up Pulumi, you're basically using the programming language that you're familiar with to spin up the infrastructure. That first part is done. It's basically like a bit a bit of immutable in some way. But when it's mutable, but there's some little bit of immutability somewhere. But then when you reach the point of installing the Linux package, let's say on the VM, you're actually going to need like a specific way, because with Pulumi, actually they mentioned that you can have integration with various other tools. So for example, it's something that I've not checked out before, whether you can have an integration with Pulumi with Ansible to then now like install the packages on your Linux system. But I know it's possible with Terraform because that's something that I've done. I'm not so sure. Not really done it with Pulumi. I've not really had that integration between Pulumi and another automation tool that like Ansible that can be able to install packages of that sort. So I don't really have a confident answer to kind of like address that. Uh, the other thing is, the other thing that you shared is if you have like existing infrastructure Linode. So since Linode, since Linode is not like okay, if as I'm saying here, you can see Linode has some providers. I don't know to what depth, because they have a few providers. So if you're going to move existing environments from Linode to, just to get your question clear, like you said you have existing infrastructure in Linode, but you do not want to affect it. Like, how would you do that with Pulumi? Is that what you said? No.
Yeah, it was more kind of similar to that, but what I picked from the question was there's infrastructure on Linode, and say you want to move away from Linode, say to another provider, then you know, how would you configure those files such that you can easily provision the same thing you have in Linode, say on AWS. I think if we picked that right. Yeah, but he has jumped off. I don't know. I think it's network. Yeah.
Okay. Yeah, I think maybe I need to get his question quite well.
Yeah.
Second question. I think is back. Hello, Daniel.
David, if you can
He
hear
said
us,
David.
could you rephrase the second question again?
Yes, sorry, my internet skipped. I just reconnected. Yes.
Yeah, second question. Yeah. The first one, I'm not so sure about the integration that Pulumi would have with a tool like Ansible.
Okay.
Or SS, but you can actually run SSH, and the integration with SSH, I'm sure that is there to be able to run your custom scripts. Yeah, I'm sure it is there. It's something that I've not done, but I've not really tried it out personally. So I was trying to find out about the second question. The second question was, what was it?
Okay. So the second question is, given an existing set of infrastructure, yeah, that you currently on whatever cloud that you're running on, US, GCP, Linux, Ocean, whatever it is, right? How do you then use the existing state of the infrastructure, the way that it is with all the Linux packages installed, application and all that? Now you want to automate the management of that existing infrastructure in its current state using a tool like Pulumi. How do you do that? Or you have to just completely, erase everything down the ground and then build it up from the ground up. How would you approach that problem?
So that problem generally in infrastructure as code, how you approach it is that you can first start with importing, but with importing the resources, some of the dependencies cannot easily be imported. So since not all dependencies can easily be imported, you have to start like from the ground up, like step by step and setting it up. So most times you find that you really have to redo it somehow. You have to redo it somehow on a step by step basis. If your actually infrastructure is set up in a complex way, because once you start using any infrastructure as code tool, you'll find that actually there are some things that you can be able to automate, and there are also some things that you will not be able to automate. Like some of the resource providers are supported, some are not supported. So you may find that in your existing infrastructure, there are resource providers that are actually not supported yet. So that is why it's usually a difficult thing to kind of like do importation. It's usually difficult to do that import and then start managing using that import. So it's a common thing. Most times you start slowly and start redefining infrastructure slowly. So if you have like 5 servers and they're set up in a similar way, maybe you can start with one server. Personally, that's the approach that I've also adopted multiple times. Look at the current setup of how my things look like, and then start phasing out, create the code that is required for the infrastructure as code for setting up those environments in that specific way. And then start speeding it up slowly until most of your infrastructure is actually defined by code. So yeah, it does it takes time. It's not usually like it's not easy to find somewhere where you can easily import, which actually reminds me I saw I saw a meme yesterday which was about ISA migration. Let me just share it with you here. It's a funny one.
Yeah, it's also
Whereby,
that one.
yeah, yeah, it is something that takes time. Like, so this looks like someone wants to import, like you can't really import everything. Like you start slowly by you replicate what you currently have slowly until you have most of your infrastructure defined as code. Even with tools like cloud formation and ARM templates, Azure Bicep, it's usually the same thing because those tools have like you can export your existing infrastructure, but when you export, you'll find that some of the things cannot be created like cannot just be created by you cannot just create them easily by or can easily manage them when you do that export. So yeah, that's my view on that. It depends on the complexity of the infrastructure. Most times you would start by replicating slowly.
Yeah. Hope, David, that was insightful. Yeah.
Yeah.
And then
So
just a quick one, Calvin. Are we going to have maybe this goes to Stephen? Are we going to have access to the repo of the code that you've been sharing here?
yeah,
Actually, over to Kelvin on that.
it's actually public.
Yeah.
Yeah, it's
So,
public.
Paul in the chat wanted the slides. Is it possible to add them set to the repo? I'll be tagging
Oh
that.
yeah. Okay.
Be tagging that in.
Put them up there.
Yeah.
Just commit them as well.
I think that's the best way.
Mm.
Because I'll be tagging that in a follow-up post on LinkedIn. We're also going to be uploading this recording to YouTube. Yeah, so we shall be sharing a follow-up post in the group, the LinkedIn group, at least for future reference. Yeah.
Okay.
Are there any questions from the chat?
Just one more from me.
Yeah.
So for anyone who wants to start playing around with the tool Pulumi and all that, what's the best way to do that? Is there like some free credits that people can use, a sandbox, free trial, or some things that people can
Yeah. Yeah. So there is a free trial. Pulumi Cloud has a free trial. Pricing. Let me as free trial for Pulumi Cloud, but for the cloud platform that you're going to use, you have to have that is separate. But for Pulumi Cloud, there is a free trial for it. That is separate. Example, if you want to use Azure, AWS, GCP, you have to have those environments. They don't like provide those for you. So maybe you can have like free trials to AWS.
Insightful. I think David, that has been answered. Probably.
Yeah, sure.
Yeah. Any follow-up questions from anyone before we have closing remarks? You can feel free to unmute.
I didn't get a question on drift detection. This is usually a common question.
Probably
Yeah,
good.
yeah, it's So for example, let's say you change your infrastructure via code. That doesn't mean that someone cannot change it when they go into the portal and configure stuff. So diff detection is able to detect and report something that was changed that that is not the same as nothing that was changed that is not the same as what was declared in the code. So something that was where someone didn't really follow the process, whereby someone just went into the GUI and changed things. So diff detection is able to detect that this is not the current state of the cloud infrastructure is not the current state of the state file that we have for Pulumi, for the previous deployment that we had. So yeah, this is a common thing, especially when you have teams with multiple cloud engineers. You could change something, you could do something in code, then someone goes into the portal and and just changes the something.
That's a very insightful one because that always happens.
Yeah. So for David's question, that's for the cloud platforms, for AWS, GCP, and whatever, you just need to set up free trials for that. But for Pulumi, they have an always free plan. This is actually what I'm also using. But for the cloud platforms, I'm having my other stuff, my other subscriptions.
Yeah. I would say, in case there are no any further questions, probably I'll take this opportunity to have closing remarks.
It's yeah. So my closing remarks. This was just an introduction to Pulumi. It's I try to keep it as simple as possible. There is more to Pulumi than what I've just shared. There are more capabilities than what I've just shared. Some things, most of the things you'd find them in their documentation. And it's also good to assess the different tools out there. You can still assess Terraform and see how it is, assess Pulumi, everything, assess everything out there. But in general, the infrastructure as code journey is basically like an application development journey. It takes time, and also the adoption within the team. It's kind of like a marathon to implement infrastructure as code. And with Pulumi, it makes that a bit of a less strain compared to many other tools out there because teams are using languages that they're familiar with and practices that they're already familiar with. So thanks for the session, Steven. Hope it was good. And I hope the community grows and we also learn from other people as well.
Yeah, I would say we discussed this initiative David is on call. I also shared with you, and I would say this is one of the first strides because Kelvin can testify. We first had a simulation before, having this actual session, hours before the call, and, discussing the go-to platform to deliver the best experience. Because at the end of the day, we also needed the recording. And, when I reached out to Kelvin, it was really positive on leading the first session. And I think basing on what we have had, I think you can see the quality of content being delivered. ISC big, is a big sea to navigate. And I would say from my own experience, there are so many tools out there. So getting started, sometimes, if you have people to share with, it's very easy for you to get started. But I would like to say and share a vote of thanks to Kelvin. Thank you, thank you, thank you, thank you so much, for dedicating time, putting in weeks to prepare this content, setting up these environments. As you can see, preparing the slides, and dedicating the time, because this is, we didn't even say we're going to pay or do what, but this is Kelvin giving back to the community and sharing his knowledge and exposure in the DevOps field. Yeah, so I would say thank you so much, Kelvin. Thank you, thank you, thank you. Asante sana.
Yeah, you're welcome. Thanks. Thanks
Yeah,
for
and
the
we hope
invite.
you could again share more sessions. You could lead more sessions in future. We shall be engaging more engineers, and also probably discover a couple of aspects from developers, from DevOps engineers, from cybersecurity gurus, to have that wide aspect of DevOps as a field, because DevOps cuts across, and we hope we can deliver the best experience. Yeah, and for those because we had over 21 signups, and also probably we shall be sharing this recording on YouTube to benefit anyone out there wanting to start their journey with Pulumi. As you saw, Kelvin strive to deliver the fundamentals, regardless of the programming language you use, as long as you configure your repository, define your infrastructure, push to GitHub, have CI/CD pipeline set up, make deployments. I think I would say, in my opinion, I've really got the fundamentals, which has really been crucial. And I believe this can help anyone out there. Yeah. Also, I take this opportunity to thank everyone who joined before and those who have stayed with us up to this time. Yeah, thank you guys so much, and hope probably you've learned something. Probably you can feel free to unmute and probably share with us your closing remarks, or probably what have been a few of your key takeaways from this session. Yeah, so Paul, you mind unmuting and probably sharing a few remarks you've taken from this session before we wrap it up?
Good afternoon, everyone. Yeah, the session was very insightful. I was able to pick one or two from the session, how to be able to at least a question on how to start, and that were answered also. So it gives me an insight to try it out. I've not used it before, so it's like an eye opener. Be able to look at it and see what I can do. So thanks. Steve, for this. It was very, very good. Appreciate.
Yeah. Sang, you mind sharing your key takeaways? No, you texted in the chat. Vote of thanks. Okay, he has texted in the chat. He has really liked the comparison between Terraform and Pulumi, and he has really got more insights about Pulumi. Yeah, that's really nice. I see Keith. Any few remarks from you?
First of all, thank you, Steve, for starting up this initiative for DevOps, and also the team that has coordinated David rather, and then of course the first speaker, that is in Kelvin. This was informative. Yeah, and I hope more of this happen. It's always nice learning a few tools, right? And seeing how far and extensive Pulumi is just from these foundation steps that we've been shown. I will definitely use it. Yeah, but yeah, thanks for this platform. And hopefully we have these sessions monthly at least. Yeah, but yeah, thanks.
Yeah. Yes. Thank you guys again. David, you want to say something closing?
Yeah, I just a vote of thanks to Kelvin. This has been absolutely thorough for me. I've never interacted with this tool before, so this is an eye opener. And now I have clear understanding between it and Terraform, which is been like the more popular version. So this is going to help me deciding exactly which tool to adapt for my next project. So and kudos to Stephen as well for putting this together. I know it takes a bit of time, But yeah, this is really awesome, and that the recording is going to be on YouTube for everyone else to listen to. So for those guys.
Yeah. I'd say thanks everyone. Thanks, Kelvin. Guys, we did this. Yeah, it's not easy to pull it off, but I know we're looking forward to organizing more sessions. Probably we shall be sharing more on that around topics. Yeah, so topics that we feel probably we need to get in the gist of. Yeah, but at this point, allow me to say have a great weekend, everyone. Thank you for your time. We look forward to the next, and thank you for being part of the Kampala Devops community. This is first of many. We hope to have more, and we hope to root for the best. Yeah. Thanks, everyone, and great weekend.
Bye.
All right. Thank you. Bye.